All right, so this time we're trying to prove that the sum of the first n square numbers is n times n plus 1 times 2n plus 1 over 6. And we're going to start the same way. So this is our p sub n statement, so I'm not going to rewrite it. If n equals 1, then we would have 1 squared is equal to 1 over 6 times 1 plus 1 times 2 plus 1. So 3 times 2 is 6, 6 over 6 is 1, so that's true. So now we assume n equals k is true. And I'm actually going to write that down. So we're saying that 1 squared plus 2 squared, 3 squared, and down to k squared is equal to k over 6 times k plus 1 times 2k plus 1 is true. And now we're going to let n equals k plus 1. So we're looking at the next term. So I'm going to take this and add the next term. So 1 squared plus 2 squared plus 3 squared plus k squared plus k plus 1 squared. So we're trying to show, let me make a little bit of space. We want to show that that is equal to k plus 1 over 6 times k plus 1 is k plus 2 times 2k plus 1 plus 1. So we want to work with this and hope that it ends up looking like this. Well, we know those first k squared terms, those first k terms are going to give me k over 6 times k plus 1 times 2k plus 1. And now I want to add in my k plus 1 squared. So to add that in, I'm going to need a common denominator of 6. So I'm going to make it 6 times k plus 1 squared over 6. And then I'm going to expand, simplify, and then hopefully put it back together. This term is going to end up being 2k plus 3. So that's what we would get to before we could take it back to this. So let's see what we've got. Up top, I'm going to have k times 2k squared plus, that's going to be k plus 2k is 3k plus 1 over 6 plus 6 times k squared plus 2k plus 1 over 6. Continuing to simplify. Let's put in an extra page. All right, maybe. Or not. There's all my extra pages. All right. So we have simplifying 2k cubed plus 3k squared plus 6k squared. So that's going to be 9k squared plus k plus 12k is 13k plus 6. That's all over 6. So I'm hoping to rearrange this so that it factors and gives me k plus 1 times k plus 2 times 2k plus 3. Looking at this, I don't see any sort of obvious way to factor it, so I'm going to go back to my synthetic division. If it factors by k plus 1, then that would mean that negative 1 would be one of my solutions. So 2, 9, 13, 6, 2, 2, 11, negative 2. That's going to give me 7. Negative 7 is 6, negative 6 is 0. So I know k plus 1 times 2k squared plus 7k plus 6. That, of course, is going to give me what I want, k plus 1 times k plus 2 times 2k plus 3. So 4k plus 3k gives me my 7k. All right, that means I can rewrite this as k plus 1 times k plus 2 times, and I can separate this back out as 2k plus 1 over 6, which equals my right-hand side. So I've proven it to be true.